Welcome to Video Assist. We're looking at elevator type problems in this video. More specifically, we're looking at the type of problems you can also find in Unit 1, Section C, Activity 3. Most elevator problems involve a mass which is being raised or lowered, often attached to a string or a rope. However, elevator problems can also resemble the one that is shown here. Here we have a 70 kilogram fireman who slides down a pole accelerating at 1 meter per second squared, and we're going to assume that 1 meter per second squared is downward. What frictional force acted on him? Now we know there had to be some friction, because otherwise the fireman would be under free fall and would be accelerating at 9.8 meters per second squared. So in this particular case he's still accelerating downward, but at a slower rate. When you get a problem, any elevator problem like this, you should draw a free body diagram. And the free body diagrams for elevator problems are very easy. They're almost all the same. You simply have a mass, in this case the fireman, and you have the force of gravity. And then often you have an upward force, which is often the force of tension on a rope. But this fireman, he's not attached to a string or a rope. It's friction which is acting upward in this particular case, which is slowing his descent. So the free body diagram looks like that, with only two forces. We start off with Newton's second law, which says that F net equals ma. Make sure you understand that rule. That says that if you add up all the forces, that'll equal the mass times the acceleration. Well, let's find the forces, the sum of the forces. But before we do that, we should identify the direction of the acceleration and what direction is positive. In this case, the direction of the acceleration, I'll draw it as a squiggly line, is 1 meter per second squared downward. It is wise, or a good idea, always to consider the direction of the acceleration to be positive. It just makes things a little simpler. I'll put down also as positive. Okay, now we're ready to substitute in the forces to find out what F net is. Well, there are only two forces, Fg and Ff, and Fg would have to be positive because it's acting downward. Ff, however, is negative because it is acting up, so I will subtract Ff equals ma. We're almost finished. Fg is replaced by mg minus the force of friction equals ma. Now you can substitute in the values. We have a 70 kilogram man, multiply g, always 9.8, minus the unknown, force of friction, equals 70 times 1. Solve for Ff. I will not do that in this particular video, but that gives you an idea how to begin an elevator problem, always with a very simple free body diagram, and then substitute into Newton's second law. Good luck.